Welcome everyone to the session Supercharge Power BI with Azure Synapse Analytics. A session I've been very excited to hold, and it's one of my favorite, both because it combines the two of my favorite tools, but also because the title contains the word supercharge, which is of course a very action-packed word. So I'll try to live up to that. So, as said, my name is Mathias Halkjær Petersen. I'm a principal architect in data analytics from a cross-European country called Fellowmind, a consultancy. I am very active on LinkedIn for those of you who don't know already. So feel free to reach out, connect, or write me a message. I'll usually respond. And for those of you who are high-tech, there's a QR code on the screen that you will still have maybe 10 seconds or more to take a picture of if you want to. Besides being active on LinkedIn, I also have an online blog called fluxbi.com. So that's fluxbi.com. I actually think you can also do flux.bi, but anyway, both should work. Where I'm writing more and more content on, well, you guessed it, Power BI and Azure Synapse Analytics. And I have a special passion for topics that cross both of these products. So let's get to it. We're here to talk about, not me, but we are here to talk about these two tools. And I may want to say, yes, we are talking about Power BI and Azure Synapse, but we're also talking about Azure as a whole together with Power BI, because as you'll learn later, Synapse is more than just a tool. It's actually a bundle of different Azure features and more. But let's start by talking about Power BI, which I assume and think that you all know and love already, and talk about what I see as some of the limitations, some of the disadvantages, maybe even in Power BI, some of the features we're lacking that I believe that Azure Synapse Analytics helps making up for or helps improve. So let's start by talking about Power BI. And especially let's talk about the concept of end-to-end analytics in Power BI. Because when I judge Power BI, or when I use Power BI, or when I investigate the usages and where we should use Power BI or not, I like to think in the concept of how do we make a proper end-to-end data platform that covers all the needs of a given organization, a given customer, client, etc. So I always want to think in end-to-end and have like a proper architecture in place. So let's explore the concept of doing end-to-end in Power BI. And let's start by talking about what we can do, or at least what we could do a few years ago. So the normal thing to do in Power BI, and even though there are more features than what you'll see on the screen, this is also still the typical way to start working with Power BI. I still see tons of organizations who utilize Power BI in this exact way and don't know any other features within Power BI that will do more than this. But the starting point here, of course, is we start building in Power BI. We make some data sets, we make some reports, we publish it to the service, we start sharing them with our colleagues and our peers. And of course, we can orchestrate and refresh these data sets in the service. This is one of the core features of Power BI, and Power BI does these extremely well. It's a very, very high-tech, very capable semantic layer and very capable reporting layer of an end-to-end solution. So that's very cool. Now, even within this, there's some people haven't realized the power of having separate data sets that work as a semantic data model, where you can then have multiple reports on top. That really helps with the whole end-to-end analytics. You can make enterprise data sets where people from across a whole organization can make their own individual reports and explore the data. Very powerful, but we can do that within Power BI. It's definitely within the realms. I would even say it's one of the biggest strengths of Power BI. today. So we have all that, and that looks good. And for a lot of people out there, they don't really think they need more than this. So the question is, do they? What are the missing pieces here? Well, if you ask me, this is fine in some cases, but I feel it lacks one of the fundamental roles or layers or steps in an end-to-end data platform. So there's more than what we can do in Power BI. Sometimes we are blind to the fact that there are more things, because if we just know the tools within our Power BI tool, we may not be aware that there are solutions or that there are concepts out there that we're missing out on. And if you ask me, some of those are proper ingestion of data, a proper clean layer of our data, and then a proper distribution and curated layer. And when I say proper, it's because theoretically you could do all of these in Power BI using awkward designs, but they don't really do it well, and there are limitations. So here's the limitations I've found. If we talk about the first one, the ingestion layer, the ingested data. In Power BI, we are not able to, at least not from these tools shown here, we're not able to materialize, we're not able to persist the data that we're ingesting before we're doing any transformations on them. So in technical terms, we're not able to do a proper staging of the data, a one-to-one copy from our data sources, and that has its limitations. The second thing is the whole transformation within our data set, that kind of happens behind the scenes. We cannot see the individual steps, the individual transformations. It's kind of happening at one big out of sight layer, out of sight thing. And that also means it is hard to audit. It's hard to track the steps and the lineage of what's happening in between. And it's hard to do any sort of quality checks and logs on those transformations and the data coming out from them. And finally, we have this inaccessible curated layer. So we can have a data set that is then the source of other data sets or other reports. So in some way, we can curate the data and share it. But we cannot really share it outside of Power BI. So we have a degree of login here. We are logged into doing our reports in Power BI, maybe also in Excel, or export the data to an Excel or a CSV file. But it's not like we can hook up some other third-party visualization tool or have some of our Python code access the data of our data set. At least not back in the days, because things have been happening since then. And one of those things was the introduction of the data flow feature. And data flow kind of solves some of these problems. But it's hard to determine exactly which of these it solves and how well it does it. Is it a curated piece of tables? Is it a place to do the cleaning where we can do quality checks on it? Or is it a place where we can stage data? And does data flow really give us all the benefits that we need in each of those steps? I wouldn't necessarily say so. And we would quickly end up in a scenario where we then have to put a data flow linking to a data flow, linking to a data flow, and not necessarily ideal. We got other things than the data flow. We also got the fact that we can now make data sets that are connecting to other data sets through the direct query for Power BI data sets. So we can make kind of modular data sets. We can make one big enterprise data set, then we can have some smaller satellite data sets that can have a subset of that data, maybe merge with some new data and kind of have a functional area or a department bite-sized data set. So that also opened some of the possibilities of making like reusable data and stuff like that. Furthermore, we had an introduction of the REST API for Power BI, which included a functionality to query our data sets through the REST API endpoint. So technically, we can also pull data out of our data sets, also removing one of the limitations mentioned before. And then we got the data mart, or the Power BI data mart to be exact, which is kind of a new tool in the toolbox. It's still in preview and it's still a bit uncertain what is the actual the use case for the data mart so far. But could the data mart maybe be a player on having a proper curated layer? In some respect, yes, maybe. I think so. It's at least it's a good effort along the way, because the data mart allows us now to actually query our data in SQL language for other applications and stuff like that. Well, it's still filled with limitations, and it doesn't necessarily work extremely well for any use case, but it does offer some functionality to export data out of the system. And where data mart are exactly supposed to help us create end-to-end analytics in Power BI, I don't think we've landed there as an industry yet. I don't think there is a best practice that has emerged around data mart yet. So it's still up in the air. Data flows could be the source for some data marts, or et cetera and et cetera. We don't really know yet. But we do know that while data mart offers some of these functionality, it's still quite limited and doesn't compete with a proper backend data platform at all. So we still have limitations. We definitely do. We still have this outer-side transformation layer. Kind of can work around that and maybe have it in data flows, but that just doesn't give us proper tool to log if there's any data quality problems in our data, or if they've been cleaned properly, or if the pipeline has been running. And it's not designed to be a proper clean layer, if you ask me. We can sort of stage the data, but we don't get the option of storing historical data. I know for some of the experts who may be sitting in the audience that technically, yes, you can store historical data by utilizing a data flow, using another data flow as a source, and then using some incremental refresh on top of that. But for practical reasons, we cannot do it. And even in those semi-hack solutions, you would still run into the problem that if anything ever goes wrong with your data flow, then you've actually not stored your data anywhere, and you may not be able to access it. Again, there's workarounds. You could sync your data flow to a data lake, but already there we're starting to enter the domain of combining Power BI with Azure. But you could technically do that, but it kind of becomes a hack on a workaround on a hack on a workaround, and not necessarily the most elegant solution for some of these limitations. And finally, a problem that not necessarily the average Power BI user is facing, but Power BI doesn't handle humongous data very well, at least not alone. And when I say humongous data, it's because big data has kind of been a word that every company and their neighbor is saying about this. We all have big data, but at the end of the day, almost at least a very few of them have data that are so large that it becomes a problem for Power BI. So if you have millions of rows of data taking up gigabytes of space, that's not a problem at all. But if you have billions of billions taking up terabytes of space, or terabytes of storage, that is of course a problem within Power BI. Power BI handles them very well when combined with a proper backend for storing those data, with some of the premium features of Power BI, like incremental refresh, composite data models, pre-aggregates, and stuff like that. So it handles them very well, but as I said before, not by itself. It needs a proper backend to store the data. It needs a proper data platform in the background. So that's what I believe we can do to help Power BI out. We can supercharge it with a proper data platform in the background, of course, built on Azure Synapse Analytics. So to sum up some of these core benefits, and to do it in a manner that respects the title of the presentation, here are the, I don't remember the number, I think it's five or six superpowers that we can give Power BI by using Azure Synapse Analytics. So the first one is time travel. Not to be confused with the actual technical term time travel in databases, but the superpower time travel. So we can help Power BI to be able to look back into the past and see how did our data look at a certain point in time. And we can help Power BI look back across multiple points in time and start visualizing trends. So historical data and change tracking. One of the big use cases that I see could be something like if you have project planning. So at the start of the project, you may set a deadline for this project to be like 1st of February. Then when the project is running, you face some problems or stuff like that. At least you'll realize you're never going to meet the deadline for 1st of February. So naturally, you communicate that this is a problem and you'll change the deadline to maybe 10th of February or something like that, or even 1st of March. The problem is that a lot of project planning systems, a lot of systems in general, don't necessarily keep a log of how fields looked before they were changed. So when we do a new load into Power BI, we are going to see only the current deadline for the project. We're not able to analyze that this project was in fact postponed, that it did not meet its initial deadline, and more of these kind of time-based analysis of how did our data change over time. But by storing it in an Azure Synapse Analytics, we will be able to do that. The second superpower is supersize. I mentioned it before, and I'll mention it again. Azure Synapse handles massive scale data, and you'll be able to analyze those big data that Power BI doesn't necessarily handle on its own. Meaning that you should never be worried about running out of capacity, because it will, well, I'm not going to say always, but for almost all customers, that you should be able to scale indefinitely. I think that's the point. So third superpower, reflection. And I didn't know what else to pick for this one, but the capability here is that with a backend, you are able to push back some of the data into your source systems. So let's say you're doing a neat transformation of your data in Power BI, you're enriching it with some cool data, maybe even using one of the AI models in Power BI. Suddenly you have added something new to the data, something that's cool, something that can be of value to some of the systems that are source systems. So in some cases, you would want to push that data back into the source systems or across different systems. But Power BI doesn't really allow that as it is today. You can load in data from different systems and you can visualize that data and report on that data. It doesn't really do the whole sharing of data, except for those new tools like Data Mart and Dataflow that have some capabilities, but not ideal for this either. So with an Azure Synapse, you can actually expose this data and push it back into source systems or into web applications or into other platforms like that. So the fourth superpower is, I call it multi-power, because what you get in Azure Synapse regarding data transformation that you don't have in Power BI is that you get the support for multiple programming languages. In Azure Synapse, you can change your data using SQL. You can change your data, or you can transform your data using SQL. You can transform your data using Python, or even C#, I believe, and Scala. You can do it through notebooks, or you could do it through the other UI options. And you also have the possibilities to not use a programming language and still do point-and-click, low-code, no-code transformation. You can do it through the UI with pipelines or with mapping data flows. So there are just a multitude of options of how to transform your data. And that means that you'll be able to use the tool that is best for the specific purpose, for the specific task, and not necessarily only rely on Power Query for everything, even though Power Query is also very powerful. So multiple options for transforming our data. Then we have, I call it hypercognition. So that's obviously AI capabilities. So using Azure Synapse, you are much more in much closer proximity to all the other Azure AI tools, and you are able to transform the data, turn them into the format that makes sense for AI models or for AI model training, and then expose that data from Synapse into tools like Azure ML or cognitive services or something else. And finally, we have what I call regeneration, meaning that proper CI/CD and version control. I know we have something in Power BI. I think everyone agrees, I can agree to some extent that what we have today is not ideal, that it could be better. And it is better integrated if you're using Azure Synapse. You can use Azure DevOps, you can use GitHub, GitHub Actions, and you can kind of have a proper development flow with proper test cases and checks in between, and a proper version control of what are the changes from time to time when you are making changes to your data pipelines. So all these things are important, more enterprise-like features that I don't believe are completely solved within Power BI. But luckily we have other tools that can help extend the capabilities and add on those kind of capabilities of Power BI through Azure Analytics. So that was the weaknesses, the superpowers that alleviates these weaknesses, and then we have a superhero to the rescue, Azure Synapse Analytics. So I assume that not everyone here on the presentation, on the meetup, already knows exactly what Azure Synapse is, how it works, and what it does. So I'll start with the basics. Azure Synapse is a cloud offering in Azure, obviously, that has a bunch of different features, but it's not just a bunch of features, it's actually more of a toolbox consisting of a bunch of individual tools. So spinning up an Azure Synapse Analytics instance will give you immediately a data lake, a serverless SQL endpoint, a dedicated SQL, or at least the possibility of having a dedicated SQL pool. It can be a Databricks cluster, it can be mapping data flows, it can be Synapse pipelines, equivalent to everything you get from Azure Data Factory, except for maybe a few small features. And you also get the Synapse links, which provide very easy point-and-click integrations with some of the most used Microsoft source systems. So you get a bunch of tools, and not just one tool, not just a single feature, a bunch of tools with each individual features, but neatly packed together in an easy manageable package where everything is pre-connected to each other and works together out of the box. And you get much more than those mentioned here. but those are, as I see it, the core components. So you get all this out of the box, and they already wrap together and they work together, and you're good to go. So one of the often asked questions is, well, that sounds expensive. What does it cost me to get started? Because I'm just a Power BI user. We maybe have a few licenses in our company and are paying maybe hundreds of dollars per month for licenses. So there's no way we're going to be able to start paying something that will cost us thousands of dollars or something like that. So what does it cost to get started? And I always like that question, because the answer is nothing, almost nothing, or nothing at least to begin with. So if you create an Azure Synapse analytic instance, it will cost you nothing from the moment you start it. I mean, granted that you don't touch it or play with it or do anything, it won't cost you a thing. It's starting out with all of these neat tools from the slide before. It's starting out with all of them kind of turned off, in the sense that there's no consumption running. You don't pay for a lake storage because there's nothing in that lake yet. You don't pay for the dedicated SQL pool. You don't pay for the serverless SQL, because a lot of them are consumption based. So you only pay when you start using them, but those that aren't are turned off by default. So we have the dedicated SQL pool in there, which starts at around $1,000 per month, but that's turned off per default. So you don't necessarily need to use that. And most of the instances I've worked with in Azure Synapse, we actually don't use it, because those only start to become relevant when you're working with data of a very high magnitude. So most of the other services, as I said, they're paid per consumption. There's a complex pricing behind it. It can be sometimes difficult to estimate upfront what will it cost, what won't it cost, and stuff like that. And the mistake that I see a lot of people run into when they try to estimate this is they go to the Azure calculator and they don't know what to type in on the consumption numbers, so they rely on the baseline. And depending on which baseline you start out from, that can tell you that this is going to cost you $10,000 or $15,000 per month as a starting point, just when you click let's see what it costs in there. So that's not necessarily the most precise way to judge how your implementation is going to, how much your implementation is going to cost. So we can do other things. I always like to recommend do proof of concepts on subsets of your data that are kind of representative of your whole data. And then you can easily calculate what did it cost for this subset. Then we can just calculate what will it cost for the whole data and multiply that with the amount of days or month for a whole year, and we kind of can calculate an estimate on what will it then cost for a year. But in my experience, it often turns out cheaper than anticipated. Not always, but often. And my cheapest implementation so far ended up costing the customer a recurring cost of a little less than $10 per month for a whole Azure-based backend data platform. I think that's pretty amazing. But if you're worried, and you should be worried and careful when you're working with cloud things, because cost can go up, I definitely recommend look into using Azure budgets and cost alerts. You'll get a warning if you're ever crossing a certain amount or a certain percentage of amount, and it even has the functionality to predict what will be the cost for the month, and based on that number you can also set up alerts if that number becomes too high. So contrary to a lot of people's current assumptions about Synapse costing, it is very flexible. It can start very cheap. It can of course also become expensive because it's a toolbox. It's not a single tool. But you can definitely keep costs down if you are doing a cost-conscious design of your data platform. So we talked about end-to-end analytics in Azure in Power BI. That didn't quite do the job. So the next question is, can we then do end-to-end analytics in Azure Synapse? Well, we have a bunch of tools. It's a toolbox, so we have a bunch of options. We can ingest data from our sources. We can clean them in Azure Synapse. We can also store it under ways and build up this history I was talking about. And we can have the pipelines in Synapse orchestrate the whole thing, making sure that the things are being started and stopped in the right sequence. So it does that really well. And we can even visualize data in Synapse as well. So Synapse is also capable of doing some of the end-to-end capabilities. Yeah, and you could add other tools to it. So before we continue, let's have a demo on Synapse. So those of you who are unfamiliar will get a sense of how it looks and how it works and what it looks like. So Synapse out of the box comes with as I said, with a bunch of tools and a whole new UI, and it would take a session in itself to do like a Synapse 101 where we go through what each of the element does and where you find each of the things. But we can do the primary navigation bar out here. So there's a home button. That's normal. Then we have a data button that handles stored data and data sets and stuff like that. Then we have the develop that handles kind of code-based stuff like saved SQL queries, notebooks, stuff like that. And the pipeline for doing, or the integrate button for doing actual integrations. And finally, there'll be monitor and manage. So there's like settings, monitoring, logging, and then we have a bunch of our developer tools. So the integrate one, I think that's the primary point of interest for a Power BI user. So we can integrate data. We can pull data into a Synapse with this option. So I can go and use again a UI based approach. I can create a new pipeline. We'll have a blank pipeline here, and I can go and say, well, I want this pipeline to ingest some data. Fine. I should probably have better naming convention, but you get the point, I guess. Then you'll have a bunch of activities here that do different things. But if you ever work with this, you'll find that there's one that is used far more than most others, and that's the copy activity. And copy activity does almost what it says it does. It copies data from one point, from source, and it pushes it into another source into what is called a sink. So it takes data from a source and syncs it to a sink. Yeah, that was a bit of a word salad there. Great. So there's some prerequisites that needs to be set up to work with data in Synapse. We need to, but luckily the UI helps us with that. So we need to have something called a data set. And if we don't already have that, we can just click the new button, and we get a bunch of connectors, templates kind of things that will help us set it up. And we can go get what we want here. In this case, I want to connect to an Azure SQL instance. So I'll just find the Azure SQL database connector among all those available. And we can call it DS for dataset with maybe some description here. Let's just call it demo and a date, just to make sure I don't duplicate with any other I created. Then it needs something called a link service, which is kind of a definition of a connection to a source. So that's where you handle the authentication and everything. And we'll do the same thing here. Linked service to demo. Whoops. 11 first, yeah. So I can, if it's part of my Azure subscription, I can add it here. I can enter the name manually. I have it here. Running into a problem, it seems, but it should be fine. So I have here the source, and it will have a database name. In this case, it is an AdventureWorks. AdventureWorks instance, and we can just pull this one. And I can do SQL authentication. I can do other sorts of authentication and set this up. Now I'm just gonna cheat a bit because I actually don't remember the password for the SQL authentication account. So I am going to reuse a pre-cooked connector here. So once we set up this link service, and then we come back to the data set and we need to define what table we want to connect to. The smart thing about pipelines here in Synapse is that we don't need to hard code this into the data set. We can actually leave it flexible and have it be parameter driven. So I open the data set for more configuration. I can go and add some parameters here, for example, like a schema or a table and a table. And go back here into this table definition things. I want to edit it manually. I add this dynamic content to it. And of course, these things are not, requires a bit of practice, but once you've done it a few times, you get a hang of it. So now I've made it dynamic based on the parameters. This means when I go back to my original pipeline, you see, I needed to actually prepare quite a few objects, but the whole system kind of nudged me in the direction of just doing it on the fly, which worked out well for us. So if we go back to the data set, I now need to define what is the schema of what I want to connect to and what is the table. So I can in this say it's called sales and it's called fact internet sales. I actually think this is not correct. So let me just double check in the backend here. Of course. Am I lucky? No. I'll use my rework here to check quickly. Yeah, it was sales overheader. Wait, what? We'll use this one. So sales overheader. And we could change this to be sales order lines instead or something like that. So I'm not actually sure the table I get the name right, but if I pick sales order header here, I'm connecting to that data. So I preview here and check that, yeah, the data looks right. Everything's good. Sorry about this. Everything's good, and we can commence to the whole sync aspect. So the sync is the same principle. So you need to create a link service or a data set, or even reuse the one from the same source or a different source. So you make one for where you want to land the data. Now in this case, I want to land the data in our data lake, because if you don't know it already, data lake is a flexible, very cheap way to store data when after we've pulled it in. And let's us put these files into a cheap storage. So I will add the what's it called? So Sandbox Supercharge header. Yes. So I'll add here a file system that's called Sandbox, and we can create a subfolder here that we call demo. I'll give it a name, for example, sales order header. And now I defined everything I needed to actually copy my data. So now it's similar to loading into Power BI. Now I can load it into my data lake, and we can click debug, and it'll do a trial run and check that everything is okay as it should be. And it runs for some time. And we can even check after it's done. It's done, it's succeeded, and we can even check some statistic about what happened. And in this case, we can read that it read about 32,000 rows, and it saved the same amount of rows into the data lake. And if so we just copied data into our data platform, and that's pretty neat because that means we can also start using this data now for something like Power BI. So we loaded in the data, and as I said before, our data can be kind of viewed through the data tab over here. And within linked, you actually have here the linked data lake that we just saved it to. And within the sandbox here, we have a bunch of folders, because this is my actual sandbox. And one of them here is Supercharge. And that's not the one we used now. One of them is also demo. Yeah, I've used that name before. This one. So in there will be a file, which is great. Now, I won't be able to do anything with the file, but that's simply because I forgot to name it .csv. And that should, of course, have been done inside the pipeline. So we can do a quick fix here and write add .csv to it. And next time it will save the same file. It will be a proper CSV file. So we have the data saved here as a CSV file, which is neat because tomorrow we could actually have put made the path dynamic, and we could have added in something like a date to the name, something like UTC now, and then the rest of it that needs to be dynamic, and we can try to run it again. I'm not that patient, if you figure. Great. So now we ran the job again, and what you'll see now is that it has. You see here, I added to the path. I added something before this space means I added actually a path to the file. I added a folder. So now the file is actually saved within a folder with the timestamp of when it was loaded in. And this means I can store my data from different points in time. I can start doing something like only making incremental loads of the change data and again store that with a timestamp. And we don't have to rely on overwriting the data every time we load it in. Which is neat because that makes us able to do stuff like historical data analysis. But what if we want to do some analysis on this data? Well, there are some options, and one of them is using the serverless SQL as an endpoint for this. Now we can just go to the serverless SQL and we can code this by hand. Or we can let the UI help us get the right code out of the box. So I can actually find a file here, for example, this CSV. I can have it generate a new SQL script. I can do a bunch of different things. I could even make a notebook where it's loaded into a data frame and stuff like that. But for now, I'll just make a simple SQL script where I want to read these data. So I'll just do a top 100. And it automatically generates here a new object, a SQL script object with the code that is needed to access this file. And I can try to run it in SQL. That's not good. Let's just rely on what I've done before. So using one of the files prepared for the demo as a backup, I am now connecting to a customer table from the same source, was copied over, and it wasn't saved as a CSV actually, it was saved as a Parquet file. CSV is good for demo purposes because I can actually go here to the file and in my data lake and actually check its data, where the Parquet file is more kind of obscure and hidden. But in most cases, Parquet makes really good sense because it's super compressed and it has columnar storage, so it's good for analytical purposes. So Parquet, good option in general. So I can now query my file. I can query my Parquet file with the select statement, but I can also do more and create an actual view on this Parquet file. For example, a view called raw customer. So I can try to run that and it'll create my view, or in this case, alter it. So doing nothing. And now I have a view on my serverless SQL endpoint for my customer data. I could have added different files to the same query here, so I could start tracking changes over time and stuff like that. It would be the same principle, but just with a bit more advanced SQL code. This also means if I now go to my serverless SQL database, where is my serverless SQL database? Huh. It decided to hide. I am just going to approach it differently then. So I don't seem to be able to find it in the UI. It's usually there, so I don't know why it decided to hide. But luckily, it's a SQL endpoint, so we're not forced to use the Synapse the UI. We can actually just connect to it from our favorite SQL management tools. There could be something like our good and trusted, but slightly old SQL Management Studio. So I have an endpoint here. This is an endpoint you can find once you create a servlet. You can find this endpoint in your Synapse properties in Azure. So I have here the serverless endpoint, and I can actually connect to it, and it's, as you see down here, it connected to the serverless server, and it has here the server, and in the tables, of course, it will be blank. And the reason is it's a serverless database. It doesn't actually have tables. All it has is views. You can also make something called external tables. They will be up here, but it doesn't have like regular tables with saved data. So the customer object, we just create the view here. I could go and I can query this. And same thing, I get my data, but I could do anything I wanted to. I could say I wanted something where territory ID is equal to 4, and then it would be a filtered statement over the same files saved in my data lake. I could even, if I had other tables, I could even do joins and merge, and I could do basically everything I would be able to do in SQL otherwise. So I could start using these files in my data lake as if they were SQL tables. And that's very neat because that also enables us to pull them inside Power BI. But we're running a bit short on time, so let's just move quickly back to the presentation and say, that was the demo for what we could do with Synapse. We could ingest some data, we could save it. We could even save multiple copies with different timestamps, enabling us to start generating some history. And we could create a serverless endpoint that lets us query the data as SQL, but that also means we can use a SQL connector in Power BI to load the data into Power BI. So you'll be able to use this data that we saved in the data lake. You'll be able to use it as it was SQL, so you can do queries on it, you can do query folding on it, you can do incremental loads into a data model, and you can do stuff like that. Great. So let's talk about some of the actual integrations with Power BI that we have in Azure Synapse. So we have some different ones. We have that we can integrate Power BI in Azure Synapse, that we can use Azure Synapse as a source for Power BI, and that we can host a Power BI workspace and its data inside a data lake, so that any data flows from that workspace will actually be saved into your data lake. That's a pretty neat trick if you actually want to use Power BI to use Power Query in Power BI and then save that data after you do the transformations in Power Query. Well, you can actually use a Power BI workspace that links to a data lake to do something like that. That is pretty neat, albeit maybe slightly cumbersome, but pretty cool if you have a source that's just easier to connect to from Power BI. We can use Power BI, in this manner. We can use it to ingest data into Azure Synapse by using this connection to the data lake. But also, Power BI data marts could maybe also make this process easier. I kind of regret I've written the word robust here because I'm not too sure about that. But at least it is easier to pull the data from the SQL endpoint in Power BI data mart and pull it into Azure Synapse. But there are also, there are integrations between these two that is definitely usable. So I also have a quick demo, but since time is short, I'll try to boil it down to very few things. So let's try to go to Synapse. And we go on link service here. Actually, instead of doing it, I'll just show you how it looks when it's done, giving the time limit here. So as before, we could save the SQL script. We can actually also make a connection to, that was a Power BI report. I needed to go. All my things are gone. Underdeveloped. Here is Power BI. Yes. So we're connecting Power BI workspace to our Synapse, and it will have some reports. And I can even look at the reports from Synapse. So I can even use Synapse as my starting point to look at reports. But what's also kind of cool is if I needed to do like a quick adjustment, I can actually go and change the report, make a quick little change here, add some data, and save it again. And there you go. I just edited the Power BI report from within Synapse. So there's definitely a connection there. I could also have gone and made a new report. So go here, create a new Power BI report. I need a data set to create a report, so I can pick my Supercharge demo data set. And there we go. Again, connected to a source, can start building a report. Quickly save it, give it a name. So Supercharge 2. And there you go. I just created within 5 seconds a quick Power BI report based on a data set from within Synapse. So also a neat little trick if you're primarily working from within Synapse. Yeah, and the final thing is that Synapse even lets you does not do that anymore. There were a button to create a data set. It doesn't matter because what it did is it generated a PBIX template or Power BI template that you needed to open in Power BI desktop anyway. So for data sets, you still need to do those in Power BI. But yeah, from Synapse, we were able to ingest the data, multiple copies of data throughout time with different timestamps. We could create a serverless layer on top, ingest that data into a Power BI dataset by using the shortcut in Synapse to create the dataset. And finally, you could actually create the report in Synapse, use those data based on the data we loaded in and save it. And I want to say, anything that's saved here from Synapse actually gets saved into the actual workspace within Power BI. So it's not like we're working in an isolated silo here. It is actually integrating with Power BI. So the moment I clicked save here, the report was created in my Power BI workspace, in my Power BI tenant. So I don't think the integrations are the most interesting part of these two tools together. It in some cases it can make it can kind of resemble a more unified workflow. But I think the more powerful thing is that we can do much more with the data in Synapse, and especially around saving and storing data and transforming data and combining it with using a data lake. So all in all, if you ask me, very cool, very powerful combination of tools. And when we talk about end-to-end analytics, of course, in the real world, it's not about end-to-end in Synapse or end-to-end in Power BI. In the real world, it's about how do we combine those two to make powerful end-to-end analytics architectures that do each of the tasks in a data pipeline in the best way possible. And Power BI kills when it comes to semantic modeling, data modeling, and reporting. And Synapse, the same thing for loading data in, for transforming data, for the whole flexibility of handling big amounts of data, and different ways of transforming the data. So yeah, two great tools, even better together. I think that's the conclusion for today, and I am very happy to take any questions you may have.
Thank you very much, Matthias. We've got a list of questions here. Oh, Mikkel, you're first.
Mine is first. Cool. So when you are really good on DAX and UI, isn't the threshold for moving into a scary new environment very high?
I would say if you are exclusively good at those two things, the first bridge to cross or gap to do would be being equally proficient in Power Query. That's my personal opinion. I mean, that's a more natural step to learn to do data transformation in Power BI, and then you'll be more familiar with also some of the limitations of data transformation in Power BI, and then at that point, yeah, you'd probably want to move on. But having learned the ideas behind data transformation and maybe some SQL would be a good starting point before just diving straight into Synapse.
Perfect.
Is there any guidance or rule of thumb as to when I should use a data mart, data flow, or just use data sets? It can all get a little confusing, and I sometimes wonder if I'm over-engineering a solution just to get a level of abstraction and reusability.
That is a really good question. I would like to maybe modify it and say, when should you use a Power BI data set, a data flow, a data mart, or any of the tools in Synapse? I mean, where do you decide where to do your actual transformations? That's a really good question. So I think it's always a good idea to simplify. So if something works out for you within a data set and you never run into any problems with wanting to reuse tables across different data sets or stuff like that, well, then you probably don't need to consider even data flows. Because if your problem is solved within a data set and you don't have any pains or if stumble into any limitations or anyone haven't been vocal to you about limitations like not being able to analyze historical data or stuff like that, well, then data set is fine. So if you need to do like, we want to have like a customer table that is used across our different data sets, because it can be cumbersome to update the same data across different data sets, or even problematic that we don't have this single source of truth or this single unified view of what is our customer. Well, then maybe it makes sense to have a data flow with that piece of data. And then the next step is, well, what if data flow then isn't enough? Again, and that's where some of the limitations from our presentation comes in. Data flow is not always enough to handle this case either. You can have a need to do, as I said, historical data, building up that history of how did the data look a month ago, how did it look half a year ago, and how did that move throughout time from when, for example, a project was started till when we finished it. Dataflow doesn't handle that very well. It doesn't handle humongous data very well. It doesn't handle all those limitations I talked about earlier. It doesn't have those 6 superpowers. So if those limitations are a pain to you, or you see an opportunity within those, that's the time to explore, should a proper data platform be put in place to help us even overcome that? But I would consider keeping it simple if you can, and you don't run into limitations. But at the same time, considering if you can modularize, if you can kind of reuse and modularize, create modules of components better by having either some Synapse data or some data flows or something that is reusable. So it's a trade-off between reusable, flexible components and simplicity, where by far Synapse offers the most flexibility and the most different uses of using that data across anything other than Power BI in your whole organization. But it also comes with increased complexity and things you need to know and consider and do. So it's not the simplest solution. Dataflow is a good compromise between the two. It's not that much more complex, but it doesn't have all that flexibility. So yeah, there's a continuum here between flexibility and capabilities and simplicity and ease of use. And finding that sweet spot, I don't really have like a best practice, or it depends.
Okay. Well, it depends is always a good answer.
I know.
So Mikkel's telling me that the next question is related, so we should go to that one. And I guess it is a kind of a yes or a no answer. So the question is there an argument in using a data mart for its use of managed SQL database capacity over using an explicit dedicated SQL pool when your volume of data is small and you want to keep the cost really low? Or are by doing that, are you losing loads of supercharging functionality?
So I need you to repeat the question again.
So the you early on in the session, you were showing the use of dedicated SQL pool. So you're doing lots of transformations behind the scenes in dedicated SQL pool, if I saw that correctly. And so the question really is that the understanding here is that Datamart uses a managed SQL database behind the scenes, which presumably gives you the sort of capacity benefits of doing so. So yeah. I think the question really is along the lines of, would there be an argument to use SQL database from the Datamart rather than firing up a dedicated expensive SQL pool?
First, there's a misunderstanding I need to correct. None of the things I showed today actually used the expensive part of Synapse. It didn't use the dedicated SQL pool. Right. I used the serverless SQL pool. I used the pipeline to load the data in. All of these tools I used. These are the same tools that I said for some customer. This was the solution that ended up costing like only $10 per month. This is the cheap option. So it's not about data marts versus paying a high cost. It's more about, could data mart be a simpler choice? Probably cheaper choice, because if you already have a premium, you won't need to pay for the data mart. Potentially yes, but data mart comes with a bunch of limitations. The biggest one being you can only transform your data with Power Query. So you ingest that data, do the transformations in Power Query. You can still not monitor and log those individual steps of the transformation and check data quality checks and stuff like that. But theoretically, you could have a data mart on a data mart on a data mart and have those layers if you wanted to. But you're not able to do any transformations in SQL. You cannot create, like, we ingested this table, we staged it like we want to, and now we want to make some transformations, merge some tables. We can do that in Power Query, but we don't get the advantages of actually being able to say, we want to make these transformations and save it to a new table. And next step, do some other transformations and save it to a third table. We cannot do that in data mart. It doesn't allow that. You can make queries and you can save those queries to reuse, but you cannot even turn those queries into a view that you can then use for something else. So you can still only see the data in the way it looks when it lands in the data mart. And to me, that sounds an awfully lot like what the data flow was capable of doing anyway to begin with. So I'm kind of with Matthew Roche when he said that it's maybe we should consider it more like a data flow with benefits. It's more of a data flow plus. It's a data mart is a data flow that also lets you query it in SQL and also has row-level security. So there's definitely use cases for that, but to see it in its current form as more than that, I think is you run into a lot of limitations and probably frustrations.
Hi. Are Synapse pipelines technically equivalent to data factory pipelines, or are they still reasons to use one over the other?
Great question. Technically, they both use the same code base, but the UIs are different, meaning that even though they are capable of the same things, we are not capable of making them do the same things. So there are things that Azure Data Factory can do that you cannot do in Synapse. And I think there are a few features that you can do within those pipelines in Synapse that you cannot do in Data Factory. But if you were only using pipelines for data integration and didn't want any of the other tools, Azure Data Factory is the better offering as it is now. I've had that discussion at some point with someone who wanted to decouple ingestion, so ingest the data into a data lake and then have a different tool do the actual transformation. And in that kind of setup, Azure Data Factory is the better ingestion tool. Synapse is the better transformation tool. So if you were to have separate tools for each job, ADF first, load it into a lake, and then Synapse to do the transformations. Hope that made sense.
Cool, yes. And also a question by Jojo. How does Azure Synapse compare to Databricks?
Yeah, so Synapse Databricks and Synapse are both, Databricks is built upon the open source standard called Spark. And Synapse also has a similar implementation of Spark. So if I go to Synapse here, I don't know if my screen is still sharing.
Yes, it is.
Great. So if I go to my Synapse here again and have a notebook, which is yeah, just ignore all these errors down here. Anyway, I can try to create a new notebook. So in Synapse, you also have the capabilities of having a Spark pool, and you can choose the language. Do I want to use that Spark pool to do some transformations in Python, in Scala, in C#, in SQL, or in R? And if I choose one of these, I can actually start and then write some Python code, and then it will use the Spark engine. Similar to Databricks, because Databricks is also built on the Spark engine. Now, that's where things start to get a bit complicated and hairy, because that means that in the base form, Databricks and Synapse has two implementations of the same underlying technology. So they are acting, in some sense, they are competing tools. But on top of that, Databricks is they also see themselves as a technology that other providers can then offer their customers. So Microsoft has an implementation of Databricks that's called Azure Databricks. So with Azure Databricks, you can use the whole functionality of Databricks, but it's a kind of a competing offer with their own tool, Spark, Synapse Spark. So it's two of kind of the same things. Currently, Databricks is ahead of Synapse Spark on some points, but there are, with the recent updates, some other features where Synapse Spark has implemented something that wasn't implemented in Databricks yet. So it's hard to compare, but it becomes easy to compare if you're already using the full toolbox of Synapse. You're already used to using the pipelines to load in your data, and you don't have very detailed requirements for some explicit features that Databricks may be better in, well, then why not just rely on the tool that you're already familiar with, and that's already coming bundled with all the other offerings. But for a very, I would say, if you want to maximize just on pure features and capability, I think Databricks is the better offering today. But yeah, two competing platforms for the same jobs.
Cool. We have filtered out a couple of questions more related to how do I solve my business problem, and it would take too much time to go through that in the Q&A session here. So I'm leaving the last question for Mark to spill out here.
Yeah, which is arguably another messy question, but we'll try it and see how we go. So let me jump to what the problem is from Gavin. He basically says that he's found sync data issues between Dynamics 365 and Dataverse. And so he says that the whole Synapse data lake and data warehouse build Power BI is affected by this. So his actual beginning bit of the question was, when using Dynamics 365 in combination with Synapse, do you have to connect to the Dataverse, or can you connect directly to Dynamics 365 transactional database? So how does the Dataverse enter the mix?
Will the question asker be quickly able to clarify? Dynamics 365 is also a bunch of different tools. Which is it? Finance and operations? Is CRM? Is it projects? Is it which kind of 365 is it? Because that's kind of changed the answer.
CRM would be the answer.
CRM.
Yes.
Are you using Synapse Link currently for that integration?
Yes.
And there you have problems with things that are not synchronized properly. Yeah, there's no better options than what you already have. But I want to say that it's not, there are Synapse links for Dataverse that works really excellent when it works, but there sometimes are kind of problems like you're saying. And some of those problems could be problems that needs to be solved by Microsoft. So I would actually suggest in this case to submit a support ticket and hope you reach the right person. At least not within too many levels of level 1 support and stuff like that. But they are usually able to, once you get the right person, Microsoft are usually able to help with some of those issues pretty quickly.
I'm very impressed, Matthias. I thought you were going to really struggle with that one, but gold star for you.
It's a blanket answer. I don't know if this specific problem is one of those typical problems that Microsoft can solve, but it sounds like it. So it's a guesstimate here.
Cool, wonderful. That was, like I said, the last question. Thanks to Matthias doing the session.
Thank you for having me, and I really enjoyed it.